let's do some examples. So we're going to start with number 1. This is a chain rule with e to the x with the mommy and the baby. So my mommy function is e to the u. I take the derivative of the mommy, which is just e to the u, times by the derivative of the baby, which is going to be 2x plus 3. There's the derivative of my baby. And then I'm going to put the baby back in. So e to the x squared plus 3x times 2x squared plus 3. Now I'm going to skip number 2 and 3 for just a second. I want you to try out number 4. This is the same chain rule with mommy and baby stuff that we just did with e, but now with ln. So pause the video, try out number 4, and then come back and see how you did. Okay, should have gotten 1 over t squared plus t times 2t plus 1. Now let's talk about number 2 and number 3. Number 2 and number 3 are very interesting because you'll notice they're the same exact problem. We're just going to solve this problem 2 different ways. The first way, we're going to use the chain rule. So my mommy is ln of u. So my derivative is going to be the derivative of the mommy times the derivative of the baby. And then plug the baby back in. 1 over 3x times 3. Which, if I simplify this a little bit, I'm going to get 3 over 3x. My 3's will cancel, so I actually get just 1 over x. Now let's try it with number 3, where we're going to use one of the rules of logarithms, which is if things are being multiplied inside, I can separate them with addition. And now I'm going to take the derivative of this. Well, to take the derivative of this, I take it in parts. So I take the derivative of the first part. So I'm going to have the derivative of ln of 3 plus the derivative of ln of x. Well, derivative of ln of 3 is just 0, because ln of 3 is a number, and derivative of any number, any constant, is just 0. And then I have the derivative of ln of x, which we know to be 1 over x. And voila! We got the same answers, no matter what way we did it. Okay, now let's try 5, 6, and 7. Number 5 is just a product rule. So I want you to practice product rule on number 5. Pause the video and then come back and check your answer. Okay, should have gotten 1 plus ln of x using our product rule. Now let's look at g of t. I'm actually going to, before I do anything, I'm going to rewrite g of t as negative 3t to the negative 1 instead. We don't like those fractions, and I don't want to have to go through and do the quotient rule, so I'm just going to bring the t up so then I don't have to do quotient rule on that. Now that I've got it written like this is a chain rule problem. Derivative of the mommy times the derivative of the baby. So pause the video, try out number 6, and come back and see how you did. Okay, should have gotten e to the negative 3t to the negative 1 times 3t to the negative 2. Number 7 is the first time we're going to be using our rules that we learned. More specifically, this is 3, here let's rewrite this, to the v to the 1/2, which is going to be this rule right here. I have base 3 instead of base e. So I'm going to be using this rule, or more specifically, this one, because I have a chain rule aspect to this. I have a mommy and a baby. So I want to use that one. So I'm going to do a to the u times the ln of the base times the derivative of the baby. So I'm going to have f prime of b is going to be 3 to the u times u prime times ln of 3, or the base. Now I'm going to substitute some things in. So 3 to the u is v to the 1/2 times the derivative of the baby. So 1/2 v to the negative 1/2 times ln of 3. And there we go. Okay, in the next video, we're going to talk about ln of absolute value of x, which has some weird things when we do the derivative.